Hello future engineers, welcome to my YouTube channel. If you are still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. This is problem 22, example 22. The three concurrent forces acting on the post and lying on the same plane produce a null force. So meaning to say the resultant force is 0. If F2 is zero point 0.5 of F1 and F1 is to be 90 degrees from F2 as shown, determine the required magnitude of F3 in terms of F1 and angle theta. So here is the figure. Then for the solution, we have to consider rotation of axis. So I'll call axis along F1 as A1 and along F2 as A2 as shown in the figure to facilitate the solution or to simplify the solution. And I'll call this axis 2 because it is collinear with F2, and the angle here, the measure of the angle here is alpha. So that once we obtain alpha, then theta is 180 degrees minus alpha. Then the axis along F1, coincident with F1, is denoted by A1. So first, remember the resultant vector, the resultant is 0. So it means component of the resultant along A1 or along A2 is 0 or along any axis is 0. So RA2 equals 0 equals the component of F3 is positive, F3 cosine of alpha, then minus F2, where F2 is 0.5 of F1 equals 0. So F3 cosine alpha equals F2, and F2 is 0.5 of F1. And we will call that equation 1. Then summation forces along A axis 1 equals 0 or RA1 equals 0, and the component of F3 is F3 sine alpha along A1, which is positive, this component here going in that direction, then minus F1 equals 0. So F3 sine alpha equals F1. Then dividing equation 2 by equation 1, we have F3 sine alpha equals F1 divided by F3 cosine alpha equals 0.5 of F1. Then we can cancel F3, we can cancel F1. 1 over 0.5 is 2. Tangent alpha equals 2. So that means alpha is arctan of 2 and it is equal to 63.43 degrees. Then from there, we can now solve theta. 180 degrees minus 63.43 degrees is equal to 116.57 degrees. Then substitute into this equation to solve for F3 in terms of F1. F3 sine of 63.43 degrees equals F1. So F1 can now be expressed 1.118 of F1. Now for your part, we have here three concurrent forces also, and the resultant is also 0, or this produces these three forces which lie on the same plane produce a null force, or the resultant is 0. So you are required to solve for alpha and beta. Now in the preceding problem, I solved the problem in this manner. You may solve this in a different manner. So to give you the idea, because the resultant is 0, that means that when you connect these forces, the triangle will close and you solve the triangle and show that the following would be the answers. Alpha is 131.5 degrees and beta is equal to 141.4 degrees.